Why not? Yeah. Okay. These are on.
Yeah, they're on, yeah, always on.
Okay, everybody. Oh, hang on. All good. Okay, everybody. Thank you very much for joining us for this this session. We do hear a lot about plastic and plastic waste in the daily press every single day, don't we? And it gives us a sense that we know everything about it, that we communicate, we see the news, we feel that we understand all about it. But even today I was a bit surprised. There's two bits of news that I received today. The first one you must have seen is that for the first time we've discovered in my old workplace, Antarctica, that new snow contains microplastics. And that's a big new discovery. And at the same time, I'm delighted to see that the European plastic glass manufacturers are now forbidden to advertise that their products are sustainable and eco-friendly. They were running ads in television and in the press that this plastic glass not only was produced in an eco-friendly way, was a positive benefit to the environment because it would magically clean the air or something. So at last, that's progress. So this is the kind of news that still keeps surprising us. So we want to see today if our understanding about plastics and what we can do to manage it is absolutely right. So we're joined, fortunately, by GRID-Arendal as they debunk 10 myths about plastic and provide possible solutions to the way forward. So it gives me great pleasure to introduce this session and my new friend Magnus Lovold, who is going to moderate the session. Thank you, Magnus.
Thank you very much, Paul, and good afternoon, everybody. I hope that those of you here in Geneva has managed to get some snacks and some drinks, and that those joining online are also well fed and comfortable. After that, I would say quite inspiring opening, I have the pleasure now to welcome you all to the release of Plastic Myths, What Can We Do? A new and very cool interactive tool made by GRID-Arendal, as mentioned by Paul. So my name is Magnus Lovold, a Norwegian name, and I will, to the best of my abilities, take you through this event. I'm associated with the Norwegian Academy of International Law, an association dedicated to the development and implementation of multilateral treaties. And I'm joined here on the podium by a great panel of experts, which I will introduce to you in a minute. But just first, maybe just a few words on the background. Now, we know a great deal about plastic pollution, right? We know, for example, that pollution levels are high, they're increasing at a dramatic rate, and this has devastating consequences for people, for societies, for wildlife and ecosystems. We are also aware that there are many things that we don't really know about plastic pollution. We don't, for instance, know the exact total volume of plastic pollution on the ocean floor, or exactly how microplastics, once ingested, impact on human health. Although we have, of course, our theories about this, research is ongoing, but we might not know exactly. Now, there's also a third category of knowledge, which may not really deserve that name, namely everything that we think we know about plastic pollution. So all our assumptions, all our unfounded beliefs, all these beliefs that we rely upon and inevitably invoke in our discussion about this issue. So these false ideas or myths will be the topic of the discussion that we're going to have over the next 45 minutes. It can be sometimes a difficult emotional exercise to challenge our own assumptions. Most of us, I think, have a tendency to stick to what we think is true, especially if what we think is true is rather convenient for us. Yet, I think that challenging our assumptions is critical, I would say absolutely essential, if we're going to have any hope of identifying and implementing effective solutions to the problem of plastic pollution. As you all know, intergovernmental negotiations on a new treaty on plastic pollution are currently ongoing following the adoption of a negotiation mandate at the last session of the UN Environment Assembly. And the success of these negotiations and the success of the treaty, once concluded, will require us, I believe, to question and critically assess our assumptions about how the plastics economy works. Negotiating and adopting a treaty is in itself a relatively easy exercise. But developing and implementing a treaty that will in fact solve the problem of plastic pollution is exceedingly hard. Yet that is the task currently at hand. And as a step in this process, I would like to ask you all in the audience here to really open your minds and entertain, at least for the next 45 minutes, that the somewhat scary thought that everything you take for granted about how the plastics economy works, everything that you think you know may actually not be entirely true. To help us in this myth-busting exercise, we have an excellent panel of speakers with us here on the podium today. We have Maria Sakona. She's a senior expert on waste and marine litter at GRID-Arendal. We have Kostas Velis, is an academic with the University of Leeds. We have David Azoulay, is a senior attorney at the Center for International Environmental Law, CIEL, among other things. And behind the exercise balls here, we have Andrew Henderson at Technos Innovation, which is a group sponsoring the development of solutions to future problems. So with that said, I will first give the floor to Maria, who's kindly agreed to set the scene for us by introducing the Plastic Myths web tool that I all encourage you to check out after the event at plasticmyths.com. Please, Maria, the floor is yours.
So much. And thank you very much, Magnus and Paul, for the introduction to this event organized by GRID-Arendal called Plastic Myths, What We Can Do. It is really nice to see old friends, but also new faces after almost 2 years since the pandemic. We have been working a lot all these 2 years around different environmental issues, but more focusing on plastics and plastic pollutions. Just for those who are not aware of GRID-Arendal, to mention that is a non-profit environmental communication center that is based in Norway. We are considering ourselves as knowledge providers, and we are aiming in informing and activating the global society and also motivating decision makers in order to make the changes that need to be made in very serious environmental problems. So of the issues that we are working a lot, and we have developed many projects around it, is plastics and the plastic pollution. We have gained a lot of knowledge in the last years around this. However, we have seen that still on a global scale, there are knowledge gaps, especially when it comes to the roots of plastics pollution and also to the solutions that needs to be done. There is still a lot of things that we have to investigate at this field. So under this work we have been performing all this year, we have noticed that there are a lot of misconceptions around plastics and plastic waste, and therefore we are happy to get today to present you a new website that has launched a few days ago. The website is plasticsmyths.com. It is a platform where we present 10 common myths about plastics and plastic waste. It is supported by the Ministry of the Climate and the Environment of Norway, and we really thanks them for their support. Each of the 10 myths that I suspect you can see on the monitor on my left has been analyzed using scientific evidence from publication. We have used information from grey literature, from practitioners in the field, and each myth is being debunked. The website is very user-friendly. You can download every plastic myth. It is a 2-3 pages text analysis of each myth, and also it is providing the challenges around each of the plastic myths, as well as strategies and solutions of what we can do. This work recognizes the achievements in plastic waste management, but also it points out the distance that it is left to go in order to achieve our recycling goals and in order to implement a circular economy. There are three reasons why this project, this product is very important to everyone, that it's making personal decisions, and also for those that they are carving the future of plastics. So the first reason is that we may strongly believe in something that is not true. A very simple example is that when you're buying a product, a plastic product, you may believe 100% that it is going to be recycled. However, the reality is totally different. Most of our plastic products are either landfill, incinerator, or leak into the environment. The second reason is that we might be carriers of these strong messages to others and convey them. And it is really important to understand this because we are at the time that we have started negotiating and discussing around the plastic treaty. And third is that with this project, we have put the way forward on how we can arrive where we want to go. That is meaning that if we are able to understand the misconceptions and around different issues of the plastic industry and plastic waste, and all these topics, we will be able to come up with the solutions and their strategies that they can be really realistic to be implemented. So you are more than welcome to go online to go through the different myths. There's also an online survey that we are looking for in your feedback, so please feel free to do so. It will help us a lot to improve the website. And I'm very happy that we have invited today, and thanks for accepting our invitation, our honest panelists. They are experts in their fields, and we are going to debug some of these myths today. It's not easy to debug everything, but at least we'll get a sense of what is around plastics and plastic waste. Thank you so much. Magnus?
Thank you so much for that, Maria. And I think of all the myths that you expertly bust in your web tool, I would like to propose that we focus or zero the discussion in on the issues of recycling and plastic economics. And in our efforts to find solutions to the problem of plastic pollution, we have all heard, and some of us even spoken, about the importance of recycling and the need for a circular economy for plastics. Indeed, circular economy approaches is one of the ways in which the Intergovernmental Negotiation Committee for a Treaty on Plastic Pollution will seek to promote more sustainable production and consumption of plastics and an environmentally sound waste management. But how far can such an approach really take us? Can all plastics be recycled? And how far away are we from a robust market for post-consumer plastics? So to you, Kostas, we can see in the plastic myths tool that only 10% of all plastics have been recycled until now. I have to admit, I found that number surprising. Maybe the rest of you didn't. But with all the talk of a circular economy for plastics, why is this number not higher? And what are the main challenges of plastic recycling? Over to you, Kostas.
Thank you. Thank you, Magnus. And say what a pleasure it is to be here with you. Thank you for the invitation. Yeah, it's tricky, isn't it? I mean, plastics, most of plastics is potentially on a technical level recyclable, not all of it, but a considerable part. But in fact, if we start putting the numbers together, and I've done this in different occasions in the past, and again, very recently in a global model, we see that very little. You said 10%, it might be even less. There is a bit of uncertainty with the numbers, but this is the right order of magnitude. So what is going wrong here? Well, first, we don't collect it with the intention to recycle it. We don't have the services and the infrastructure in place, being that both the most affluent parts of the world, but also the lower income developing countries. So if we don't collect it with the intention to recycle it, it's never going to be recycled. That's very clear. The second thing that is happening is, even with the amounts that you're collecting, which roughly speaking around 15% out of 100 tons of plastic waste that we're generating, only the 15 tons are going to be collected with the intention to be recycled. Out of this, only actually around half of it is going to be returned back into the economy for the production of secondary plastics and products that contain recycled content. Why this is happening? Because of all sorts of difficulties of picking the wrong materials there, or of inevitable losses in the processing. And we have to acknowledge those technical difficulties. But looking a bit more fundamentally, what happens is that we don't have markets. We have every intention to recycle this material, but where are we going to recycle it when we don't want it really to put it into the production? And certain things like PET and HDPE, plastic bottle, for example, will have a market for sure. But for the bulk of the other plastics, the plastic film, the multi-layer materials, we definitely don't have solutions to what direct them into, how to direct them into new products. Another fundamental failure here is the fact that it costs a lot of money to recycle. It doesn't come for free. Someone has to pay this money, and the fact that the value of plastic, virgin plastic, is so low, the price of it is so low, doesn't really help at all. So always the secondary plastic competes with the virgin, and always the secondary plastic will be of lower technical quality. We have to understand that. So if the only way that it is attractive is being a cheaper, more affordable than the virgin plastic, if the price of the virgin plastic is very low, the price of the secondary plastic has to be even lower to be attractive, which means makes it practically impossible to recover the cost of recycling. So these are some of the core reasons why we see these very low numbers of recycling, despite the huge efforts in our societies to say how important it is to recycle, and the huge technical innovation and other efforts to make it happen.
So much for that, Kostas. That's super interesting. And it seems to me really that the challenges involved in recycling are pretty significant at the moment. You mentioned as one of your points that the value of plastics is sort of an important factor in its recyclability, if that's a word. And indeed, we often hear that plastics, including post-consumer plastics, have a certain value. So to you, Andrew, I know that the American Society for Testing and Materials has developed a coding system which classifies plastics into 7 main categories. And I wonder, are all the categories of plastics equally valuable, or are some more equal than others? We'd love to have your take on this, how this all looks from a practitioner's perspective, which categories of plastic waste has the highest recycling rate, and why? Over to you.
Yeah, so thank you, Magnus. Just to introduce you, my expertise, that's an expertise based on failure. I have to tell you that winners nearly never learn anything. They just know it's what it's like to walk up and collect the money. Whereas people who lose often learn the reasons why they lost. In my particular case, I have a massive big hole in my bank account where lots of money used to be, which I invested in a recycling facility. And that facility was trying to do the right thing and turn plastic waste and fiberglass into usable products. Now, this failed, and the reasons were laid out by my esteemed colleague to my right. He said there's no market, and that is the reason why we failed. Now, to get to the question from my moderator about the process of classifying the different products, we were mainly dealing with LDPE, which, as you can see from this chart, is number 4. And we were dealing with HDPE number 2, and we're dealing with PP number 5. This particular group of plastics are the most collected, I guess, for recycling. They are variously difficult to recycle. As my excellent colleague Steve Wong will testify, there is no absolute simplicity to any of this process. The difficulties of doing that vary from plastic to plastic, particularly the differences between polypropylene, HDPE in one category because they're called rigid plastics. They're reasonably easy to collect, reasonably easy to deal with. However, they have the same problems as LDPE, which is the flexible plastic. Just to give you an idea of the problem, firstly, as has been mentioned, the difficulty of creating the facilities. It may surprise you that you need 1 million euros per 1,000 tonnes you're going to produce to make the line, to make the process. That means that if your factory is going to be anticipating to make 10,000 tonnes of production, multiply 1 million by 10, you need 10 million euros. That is if you wish to buy the equipment on the open market at a reasonable level. You might be able to get cheaper equipment, but generally that's it. That doesn't include the labour, that doesn't include the process, that doesn't include the building or the land, that doesn't include any of the on-costs. That's just the cost of the line. Now, if you start at that point, you know you've got to make that line operate. You've got to come up with something which is going to actually produce something. The difficulty is always contamination. It doesn't show you here anything to do with contamination. It doesn't mention it. It assumes that plastic are all the same. I want to speculate just a little bit on another point that was made, and that is why plastics are not being recycled. It's because there is, if you've got no market at the end, you've got no reason to invest the money in the future. We've already talked about 10 million euros to put down on the table. If you don't have an expectation of profit at the end, you're not going to invest. That's why recycling is going down. You cannot make a profit if you can't sell your product on the open market. And you can't be sure that you're going to produce consistent quantity or quality when you don't know where your plastic's coming from. Now, just to give you an idea of scale, if I can just stand up for a minute and ask my colleague to hold my microphone. Don't worry, ladies and gentlemen, I'm not going to give you a demonstration of calisthenics. It's just a demonstration. If you imagine that this ball represents the entirety of the plastic we produce on this planet, let's say it's between 350 and 400 million tonnes. 350 to 400 million tonnes a year. That's what we produce. Imagine that's this ball. After 70 years of trying, that's the best we can do. Look at the difference. After 70 years of trying, that's what happens every single year. Something's wrong. It's not classifying. It's not to do with coming up with a change of phrase or a better set of words. It's a question that the process is wrong. We're doing something wrong. I can tell you something about that reason. Thank you. The difficulty is that it costs so much to collect all of this plastic from various sources that already you've eliminated the value. CITIO, which is the responsible organisation in France for collecting, has told me that it cost them 1,000 euros per tonne to collect plastic from houses. That means that the society, that's all of you, has already invested more money than the plastic is worth just to collect it. Think about that for a minute. The plastic is already worthless before it reaches someone like me or my other colleagues in the industry. And then we have to get it to this place. That is where it normally starts the process of actual recycling. That's called flaking, which means we've got the material has been sorted, it's been ground up and it's been washed. That costs between 100 and 300 euros. So somebody keep and do the maths for me, do the addition. Then when we've got it to that point, we've got to put it through a processor to get it to that point, which is the granules. That costs 235 euros minimum per tonne to produce those granules. Then we can start making our product, our new products. And that's going to cost an additional sum. Now, we've already spent nearly 2,500 or 2,000 euros to get it to the point where we can actually reprocess it. But the price of virgin is passed long ago. The price of virgin varies between 1,000 and 1,600 euros. So it's clear why it happens. Now, you remember in the last COP meeting, I'm stopping in a second, the last COP meeting in Seychelles, where I see all my friends here, we visited, we talked. At that time, you remember, the barrel price for oil went below zero. That means an empty barrel was worth more than a full barrel of oil. You remember that? Great. That means that the price of plastic also went down. The price of virgin PP was 600 euros. We've got to spend 700 or 800 euros to recycle plastic before you make a margin. So that's why that situation will never change. No matter how much you talk about it, no matter how much you want it to change, we have to change the way it is structured. So with that, I've harangued you enough. I'll give you back.
Thank you so much indeed for that, Andrew. That's absolutely brilliant. And I'd like us towards the end of the discussion today to talk a bit about what needs to be done. But first, there are some, for those in the back, there are some seats free here in the front if you would like to step in. Don't be shy, it's all fine. But I would like to bring in a fourth discussion at this stage. And David, we heard from Costas, and we also see in the great GRID report or tool that virgin plastics is the preferred choice for product manufacturers because it is superior in performance, reliability, and also in most instances cheaper. But is it really? What are the true costs of plastics produced from virgin material? Are there any costs hidden behind the price tag? Over to you, David.
Well, thank you very much. And thank you very much both for the invitation. Thank you very much to GRID for having prepared such a great tool. We're talking now about one particular myth. I invite you to look at the other myths because there's a lot of ideas that can be debunked, that can be useful for how we think about it. A lot of the conversation that we've had so far is about the cost of plastics and the impacts of plastics once we've produced, used it, and only where we come to discard it. But plastic is a material, and the production chain of plastic needs to be kept in mind. The life cycle of plastic needs to be kept in mind to understand what is the true cost. We keep on hearing that plastic is extremely cheap. It's not cheap. It's just that the cost that plastic implies for society is not paid by the producers. It's paid by you and me and by all of us users, because there are indeed massive costs that exist all along the supply chain of plastics. And there are a few documents that are in some of the booths that you'll find here. One is based on a document that we've produced that is called the hidden cost of a plastic planet. There is the one you'll find here about health. There are similar documents about the climate impact. So look at this. This is I don't know if you can see it from very far. It's a little small, but this is a very simplified description of the plastic life cycle. You need to extract the fossil fuel material. You need to extract this, transport it to a place where it's going to be refined and transformed into the basic building blocks of plastics. Then the building blocks of plastics are different forms of carbons and petrochemicals. It's basically polymers and chemicals additives. And in this process of creating the plastic, you also add something that is called NIS, non-intentionally added substances. So every time you see a plastic object, what you're effectively holding in your hand is a composite material made of polymers, very long chain of carbon-based materials, additives, all sorts of additives to make your plastic colorful, solid, soft, airtight, waterproof, or whatever, and a number of unknown substances that end up in the product because of the magic cauldron that you have to put the oil through to actually create the plastic, the polymers, and the different things. And so first you have to extract it, transport it for it to be transported. Then you have to turn it into the various kinds of objects. And then you have to eliminate it, or you have to do something with the actual waste. Very often we focus on what's the impact once it's become a waste. There are possible health impacts and others. But if you look at, and that forces us to think, well, we need to make the waste disappear. If the problem is just about the fact that we don't know what to do with the waste, then let's find some magical way to make the waste disappear. And this is where the magical thinking comes in. We're going to recycle it. We're going to turn it into something else. We're going to transform it one way or the other. But if you do this, you neglect everything that is happening before it gets to this point. And what happens until this point is massive impacts on human health, on the environment, and on human rights, actually, on the enjoyment of human rights by population all around. I'm just going to give you a few examples. A lot of the plastic that we're seeing now today is made out of natural gas that is extracted through fracking technologies, for example. Extracting the gas uses and releases over 170 substances that have been identified by the US EPA, which are not known to be, radical environmentalists by any means, but they identify over 170 chemicals that are known as carcinogenics or having severe detrimental effects on brain development, on the respiratory tracts, on development, on brain development, etc. That is just for the extraction. And these are costs that you're not seeing when you're buying a plastic lighter or plastic toy, but that is a cost that is being paid. It's not because you're not paying it in the object that it's not being borne by someone. Then you have to refine and transport it. That requires huge amounts of energy, and that also requires the use of very toxic substances. One of the key substances in this process of creating the plastic is benzene. Now, benzene, we've known since the 19th century, is a very, very severe bone marrow. Well, and the fact is that to create plastic, we're releasing benzene, workers are being exposed, and whole communities that live around the petrochemical facility are being exposed to benzene. The food they grow on their land is being exposed to benzene. Again, severe bone marrow disease, and you said in the beginning there are a lot of things that we don't know. Well, we've known this for over 120 years, that this is a severe poison. Then you look at objects, when we create objects, and here I'm just going to talk briefly about the food contact material plastic, because this is one that has been studied quite a lot. There are over 12,000 different kinds of substances that get into the plastic packaging, food packaging. And out of those substances, over 1,000 are identified as very hazardous substances, hazardous of very high concern. And this is only for those for whom we actually have the data. Most of those substances that are being used have no data. The data is not available. But we know that we're here at the chemical cups. We know what the impacts of unmanaged use of chemicals has on human health. So that's another cost that exists. Incineration, same thing. You're going to release dioxins, which are some of the most potent and most toxic substances that were ever manufactured or created on Earth. And so what we're seeing is that even if we had a magical process to get rid of the plastic waste and make the plastic waste disappear, we would still be facing major environmental health and climate impacts. Because I haven't talked about the climate so far, but there are models that have been developed that look at the carbon emission of the whole life cycle of plastics. And it is calculated that by 2040, and I always have to look at the figure because I'm always convenient and my brain doesn't want me to remember that actual number. But the climate impact of plastic is calculated that in 2040 will represent the equivalent of 615 mega coal-fired power plant. That's a huge amount of our carbon budget if we want to stay under the 1.5%. And so if you just allow me to add one small thing about this, this is if we had the magical system to get rid of it. But we've been talking about recycling, and there's one thing that I want to add about recycling, and I'm sorry to say that now, but recycling doesn't exist. We can downcycle plastic, but we don't know. When you think of recycling, you're thinking of a closed loop, a circle, when you get a material and you get roughly the same amount of clean material with which you can do something. This is what we do for glass. This is what we do with aluminum. With plastic, because of the physical nature of plastic, at best, we're losing from 20 to 30% of the actual mass of the material. So, and you get a plastic of lesser quality. So you start from a whatever plastic object. You put it through the recycle stream that was just described, it goes through one circle, then it gets turned into something like a plastic bag, and then the next thing you can do with this is only burn it. And we call this circular? No, we're just adding one circle between the moment we extract the gas from the ground and the moment we're going to burn it in the form of plastic. So it's also useful for us to think of it that plastic may appear as a magical solution. The recycling, well, plastic also appears as a magical solution, but recycling may appear as something magical to make the waste disappear. But in fact, this is not what's happening. And even if it did, we would still be bearing tremendous human health and climate and human rights cost in just the idea of just producing it.
Many thanks for that, David. That is fascinating. I would like to, I mean, we have so short time and we have so much to discuss. But I wanted to dig in a little bit into the issue of virgin plastic versus recycled plastic. And I would like to have your take on this, Kostas, from a systems perspective. I want to talk a little bit what we can do, not just what the problem is, but what we need to do. So what kind of interventions would we need to put in place to make the market for recycled plastic into a viable or a robust market? Because we already heard that currently there is not a robust market. Is it at all possible?
Yes, thank you. I think there are major challenges. I think also the solution is not to get back to the caves and to not have no industry or no materials innovation. Whatever we do, there will be emissions. There will be a price to pay for it, and we are to regulate and make things work, not go backwards, but go forwards. So can the markets and technological innovation and the systems work better? I think yes, they can work much better. We can make the plastics work. They already deliver huge functionality to our society that our civilization wouldn't exist without it. So we have to find a way to make it happen. So a fundamental thing is we heard very clearly the challenges on the price, the actual monetized part of the cost that you're allocating between the virgin and the secondary plastic. We need to sort out this relationship. It doesn't really work as it is. One core aspect to make this happen is to pour more money into the system, and also that reflects the actual cost of producing virgin material, but also the actual cost enable the recycled material to happen. Product stewardship, extended or individual producer responsibility schemes might be a way to do this, but it's not the only way. But we have to sort out this relationship. If we don't sort out this relationship, it's not going to happen. Another thing is around, very briefly, around the informal recycling sector, because across the global south is the urban poor, the impoverished, marginalized, vulnerable people who actually contribute more than half of all the recycling that happens in the world, as our modeling has vividly demonstrated. We have to enable them to recycle more with better living conditions and better health and safety. And if this doesn't happen, the vast majority of plastic that is put on the market, we have no hope to reclaim it and put it back into any type of value recovery, including good old traditional mechanical recycling processes. And going a bit one last point, if I may, if we look at the long-term thing, we need to change the way we're innovating. We talked about 7 categories about plastics, but this is something created for the public, for us as non-experts to put things in the bin. That's all the purpose. If we look at the materials innovation, we have above 100,000 different grades of plastics. If you pick the combination of the polymer with the additives and the filler materials. And this huge variability does not really enable us reclaim the value we have engineered into those materials. So we have to radically change the way we're innovating and distributing and the cost and value, the costs and benefits of this circularity across the sectors, across the different parts of the society, across the countries in the world. I think we should look to that, and maybe the plastic treaty can help us, and the Debusting the Myths can help us in that direction.
Brilliant. Thank you so much, Kostas. And many you mentioned now, and also many of the discussants have mentioned the technology aspect. And indeed, one of the things that we hear is that so-called chemical recycling may solve some of the challenges with recycling plastic waste. And the resolution that contains the mandate of negotiation for a new treaty, as you mentioned, Costa, that also emphasizes the need for technologies and technology transfer. So that is obviously an important aspect here. And Maria, I wanted to ask you, from your perspective, how far can we actually reach, in your view, in terms of technologies? And how are these technologies distributed across regions or globally?
Yeah, thank you. This is a question that is being heard a lot during the discussions around plastic pollution. So from a technological point of view, we may expect that plastics can be recycled, at least thermoplastics. I don't know if you are aware of the term or not. These are plastics that can be remelted through heat, they can be molded, and they can produce new plastic products. They represent 75% of all products. However, things are not that simple. As Kostas mentioned, plastic products are not just coming in the virgin form of the polymer. They are coming together with additives. They are coming mixed with different plastics. And they are also coming together with multiple layers of other materials that are very difficult to separate. So the mechanical recycling, as we call it, conventional recycling, it is able to recycle to recycling the polymers as one. But when it comes to mixed plastics, that is different. This blend is different to be recycling with mechanical recycling. The same difficulty we face with contaminated plastic products or dirty products with food or other substances. And the thing is that we have the technology to separate. We can also clean dirty plastic products. There are facilities that they have introduced lines that they are washing their plastic products. It is something that exists like a technology. However, when you look at the time that is needed to do the separation and the cost around this, then this is the economies that they don't let these materials to find their way in the recycling industry, and are not desirable. You have also probably heard about plastics like films and bags that they have caused damage to equipment, especially the sorting phase before the core mechanical recycling. Also increasing the maintenance cost of the facilities and therefore are not being resolved. So the technology does exist, but it's not that easy. We need a good feedstock and the input. Either you have a good feedstock in your facility, or you have to implement all the economies around it, so it will be viable to have extra technologies to do all the separation and the cleaning. So the reality, most of these hard to recycle plastics, they are finding their way into landfill sites or are being incinerated. And then it comes the chemical recycling, new promising technologies from the chemical recycling industry. You might be heard about solvent purification, chemical depolymerization, and thermal depolymerization as well. These new technologies of the chemical industry, what they are doing, they are breaking the plastics into its chemical building blocks, and they are providing either the monomers of the polymers, and you're taking new plastic products, or it comes up with fuels. This is especially in the case of the thermal depolymerization. You probably heard about gasification is one of those technologies. That means that we're recovering materials, but we are recovering fuels that we are using for energy treatment. Yet the chemical recycling has been in the infant stage. We have seen them in pilot scale and laboratory. The last decade, we have seen them also on commercial scale, especially in Japan. We have seen them in USA and some countries of EU. However, the plastic waste that is being treated through this technology is only less than 1% at the moment. So the chemical recycling is coming as a technology promising to implement the circular economy somehow. However, it faces also challenges similar to mechanical recycling. It also requires very good feedstock at the beginning of the process to be viable, and also demands a great amount of plastic input. These are technologies that at which we are investing a lot of money to have the installations and also to operate them. And it doesn't make sense if we cannot find a way to feed them with a huge amount of plastics. So it could to work feasibly. Furthermore, we have seen that the chemical recycling is energy intensive, demands a lot of energy to be operated comparing to mechanical recycling. And that's why it's also being accused for environmental emissions. So to come to a conclusion, the technologies do exist to do the recycling of plastics. However, we need to better do the calculations and to do the business models around these technologies so it will be viable for the industry to operate it. That is meaning that we need a good feedstock material that needs adequate quantities of materials and so on. There are other things that we have to take into consideration.
Thank you so much for that, Maria. And we're actually we're at the end of the time we've been given here today. I mean, clearly a fascinating discussion. Before we close, however, we'd like just to bring us back to the fact that only 10% of all plastics, more or less roughly, has so far been recycled. And I'd like to challenge you a bit, each of our panelists, to outline in just headlines, 10 seconds, what's the most important thing that needs to be done or needs to happen in order to increase plastic recycling from your unique vantage points. Are you able to do this? 10 seconds, major challenge. But I would like to go first to you, David. In terms of implications of all of this for the ongoing negotiations of a new treaty on plastic pollution, what's the key lesson that negotiators should take out of this discussion?
I'm going to turn your question around just a little. The key lesson is not how do we increase recycling, is how do we lower and end plastic pollution. And markets are not going to fix physics. Technology is not going to fix physics. We're already putting out in the world way too much synthetic material for our ecosystem to support. We've passed the planetary boundaries. So the objective here is not to increase recycling, is to decrease production. So the one lesson is produce less, and the sub lesson is produce simpler material so we can actually do something with it and detoxify it. Currently, we cannot recycle it, also in part because it's very toxic. A lot of things we put in there is toxic. So keep the toxic out, simplify it, and in the end, produce less.
Brilliant. Thank you so much for that, David. And that was almost 10 seconds. Like you didn't know, to give you the same challenge, Andrew, from a practitioner's perspective. What absolutely need to happen to make recycling of plastic waste a viable business?
We'll start off with everything he said. And going further, in our booth over at the end there, you will see the poster for PAC at 2030, which is the answer of how to reduce the production by 43% of all plastic. That's 100 million tonnes globally. We can reduce it by a simple change in the way we use plastic. That is the single portion packaging in our supermarkets. Supermarkets have to change. They have to be eliminated, every single one of them. They have to be redesigned so that they do not continue to be the source of all of these millions of tonnes of plastic packages, all of which are different, every one of which has printing on it, every one of which has contamination inside it, and every one of which is not recyclable. End of story. Get rid of it. Start again.
Great. End of story. Thank you so much for that, Andrew. Absolutely brilliant. And now to you, Maria, from, please. Then to you, Maria, from a technology point of view, what's the most important thing that needs to be done to increase recycling rates?
From this point of view, I would say that we need to enhance the efficiency of both mechanical and chemical recycling. For mechanical recycling, we need to focus on boosting the quality of recyclables at the end of the process. For chemical recycling, we need to invest a lot of minimizes and reduce energy demand and improve the environmental footprint. That means also that we have to do good source separation before, and that we have to have good collection systems in places. And last, there is a need that we have synergies. We don't see synergies become mechanical recycling and chemical recycling. This will enhance our recycling, plastic recycling rates and minimize the costs.
Brilliant. Thanks so much. It's smart to speak quickly to fit a lot of words into 10 seconds. Brilliant. Thank you so much for that, Maria. And now finally to you, Kostas, from a systems point of view, which solutions do we need to develop from your perspective to increase plastic recycling?
Thank you, Magnus. I think all talked about from a systems perspective also, and maybe we have slightly different takes on that. But yes, I think the core thing, long feature, innovate these materials in a way that they can work in every respect, sort out the fact that there is no waste management for over 2 billion people around this world. No matter how we innovate and what materials we have, if we don't collect them, they will end up in the environment. We will be 10, 20, 30 years down the line here discussing about the problems of the materials. But we have to find solutions at the end of useful lifetime, acknowledging who is doing the job, and some parts of the world is the poor people that do the job have to be part of the solution.
Brilliant. Thank you so much for that, Kostas. And with that, I think we have to close this session. I would like to thank GRID, our excellent panelists, for challenging some of our assumptions about plastics recycling and how the plastics economy works and doesn't work. I'd also like to thank GRID-Arendal and especially Yeva, who I know follows this online in from Oslo, for having organized this session. I think it gave us all a lot to think about, and I'm sure it will provide very useful input to the negotiations on a plastic treaty. And in conclusion, I'd like to encourage you all to check out the great Plastic Myths web tool on plasticmyths.com, and also more generally to keep an open mind and keep challenging your own assumptions. So thank you very much, and thanks to the panelists.